Like easy buttons?
Yes.
Like you can record your own thing.
Yeah, they have soundboards that have buttons on them, and I just need a soundboard so I can. That's what they do on radio shows.
Looks like I can get you that. That was an easy button.
Yep. I used to have an easy button actually. I replaced the sound where it says that was easy with the Inception noise, the boom, right, the foghorn.
You're missing your moderator.
Yeah, I am. It's sad. All right, so what up? Here's what we're doing today. Get out that worksheet. There were some corrections I need to make to it with the directions. I'm sure you were confused. Actually, I'm sure that none of you actually did it, which is fine.
No, I didn't do it.
Which is fine, I suppose.
Oh, right in the garbage can. That was a bank shot.
Yep. So here's what it looked like.
Just
Worksheet in question.
stuff.
So we did number 1 and number 2 together in class, I believe, for this class.
Like halfway.
Half of number 2? Okay, wonderful. Then we will do more together. The back side, before we go any further, so I don't forget, look at number 4. Take a gander at number 4. Words are hard. Sorry, guys. It says 1 and 2 are supplementary, and angle 1 and angle 2 are supplementary. 3 and 4 are supplementary. So I say this twice. That's not what we're trying to say here. What we were trying to say is that angle 1 and angle 4 are congruent. That's the other bit of information you need. So when you go home and try that tonight for real, you'll need that. Everybody with me? Angle 3 and angle 4 are supplementary. You will need that. So that's all good. These are the 3 things that they give you. And that's what you're trying to prove. Turn the page, looking at number 5, A, B, and C are collinear, but like, great, but like, where are they? So here's what it is. So here's A.
You can't see.
Here's B, and here's C, and they're collinear. They're on this line. And then D, B, and F are here. I'm not sure where these dots disappeared to. There they are. They tell you that we need to prove that angle 1 and angle 3 are congruent, and angle 2 and angle 4 are congruent. For now, I didn't include this in the directions, but you know angle 1 and angle 3 are congruent because they're vertical angles, right? Scissor theorem, these guys. So we know they're congruent by vertical angles theorem. So bam, done, proof's over. No. What I need you to do is I need you to go through and prove vertical angles theorem, essentially. Okay? So don't just say vertical angles theorem, therefore we're done. No, say, look, 1 and 2 are a linear pair. 3 and 4 are a linear pair, so they both add up to 180, right? Do some subtraction, do some substitution, therefore 1 equals 3. Do the same thing with 2 and 4. Prove that 1 and 2 are supplementary, so prove that these guys add up to 180. How would you go about doing that, you think? Give me some ideas. What do you know about 1 and 2? Yeah. They're a linear pair, and if they're a linear pair, we should be able to use linear pair theorem, right? And linear pair theorem says they're supplementary. Done. 3 and 4, same deal, right? Same deal. Just some food for thought. All right, let's look at number 2 together, and we'll put this away and get to some other proofs. This will be for your health. All right. Number dos, that's right. So, numero dos. Let's rewind back to what we were talking about a little while ago. They tell you JK and KL are congruent. So here's JK and KL, they're congruent. I'm using colors, you're not. Whoops. Or at least I don't think you are. HJ and GH are congruent. Well, that's these guys. And notice the colors are different. So I'm not saying that these two are congruent yet, at least. It also says KL and HJ are congruent. Well, that's those guys. So guess what? They're all going to be congruent. Hooray for color, hooray for single tick marks, right? So they're all going to be congruent, but we need to prove that last little bit. So we've got these guys for free, we got these guys for free, and they gave us these guys for free. We need to prove these guys are congruent. That's all we need to do. So writing that out, let's start with what we're given. We are given that JK is congruent to KL, and you're like, man, this is annoying. We have to write this. It's in the directions. It will help, trust me. All right, and they also give us that HJ is congruent to GH. If you were paying attention last time, if you were here on Friday, we already had this written down. Lastly, they give us KL and HJ are congruent. So KL is a green one, right? And they're going to say that is congruent. We'll do the congruent sign in pink. To HJ. Well, HJ is a blue one. I think color helps with the organization, being able to see some similarities here, right? And we want to prove this, that GH and JK are congruent. So we're trying to prove a green equals a blue here. Here's our JK, here's our GH. Anybody have any ideas of how we might go about this? If you remember from Friday, might have a way to get it done. What?
Oh no, I was gonna say if something and something equals that, then therefore.
Transitive property?
Yeah.
I'm touching the paper, paper's touching the pen, therefore I'm touching the pen. It makes sense. Put it back when you're done. Cheyenne, did you have something to say? Transitive property? Yep, we're definitely going to use that. So I know that I want to get GH and JK together. Well, where are GH and JK? What do I know about them? Well, here's GH. And here's my JK. Only ones that appear, right? And we want to get them in the same sentence, in the same congruency equation, right? And they're separate. So somehow I need to switch out KL for GH. Or, if you want, you could switch out HJ for JK. I'm going to stick with the top, so I want to turn that KL into a GH. Does that make sense? Right? If this statement is true, then KL and GH must be the same. So I need to switch them out. What do you think?
If JK equals KL and KL equals HJ,
Mm-hmm.
and HJ equals GH, that means...
So here's what he's saying. He's saying, look, I noticed this. We're not going to call this the proof yet. We're not going to call this the proof. But he says, look, I know that's true, right? It's given to us. This is what's given. He also knows that KL and HJ are congruent, so why can't we write it like this? You see where I got that? And he also knows HJ is congruent to GH. Whoops, that's a G. Ah, okay, so now you're seeing the transitive property. Right? Cut out the middleman, there we go. So how do we do that without writing it out like that? First, we know that JK and KL are congruent, right? But instead of writing KL, what can I write here? What do I know is also congruent to KL? Look at our givens. HJ. So I'm going to write HJ instead of KL. Why am I allowed to write HJ instead of KL? What allows me to do that? What property? Not transitive. We're going to do substitution. We switched it out. All right, eyes up here so you know what's going on if you're lost, especially. See how JK and KL are already set up together, right? Well, if I know that KL is HJ, I can switch them out. So instead of writing KL here, I can write HJ instead. So that's what I did. JK is congruent to KL. I wrote JK is congruent to HJ. And I can do that by substitution, right? These guys are both the same. That way, whenever I see a KL, I can switch out for an HJ. That's substitution. So, yes, you could do this with transitive property. We're going to do it substitution slowly so you see what's going on. All right, so now we're not done. We need to get JK and GH together, right? So how do I switch out that HJ for a GH? Why am I allowed to do that? Because that's going to be our next step, right? Whoops. Wrong pen. Why am I allowed to switch out that HJ for a GH? Look at HJ. How do we know we're allowed to switch it out for GH? Because what, Autumn? They're congruent. It had already given it to us, right? HJ is GH. So wherever we see it, we can switch them out, right? So there's HJ. Let's switch it out for GH. We call that substitution again, right? Now, that's not exactly what we wanted, right? They wanted GH on the left side and JK on the right. Eventually, we're not going to care about that, but for now, since we just learned the symmetric property, we should care about it. So I'm going to rewrite that with GH on the left JK on the right. Now what allows me to switch those guys left and right? What property again? Starts with an S. Nope. Good guess though, 2 in a row. What allows us to flip that? To read it right to left or left to right. 2 plus 3 is 5. 5 equals 3 plus 2. Yeah. The what? Yep, symmetric property, right? Not the reflexive. Remember, reflexive says A equals A. So the same thing equals itself. This guy, A equals B is the same thing as B equals A. So we can flip them, right? That's symmetric property, and then we are done. Swag box. So again, if you're just tuning in, JK and HJ are the same. I know that because I have JK and KL given to me, right? So I start here, and I switch out KL for what it is, HJ. Then I notice that HJ is the same as GH, so instead of HJ here, I'm going to write GH. Switch them out. Last thing, flip them, and I've got what I wanted, right? That's exactly what they said I needed. Feel better? Okay, I'll take better. It's new, it's different, it's weird, but that's the deal. 3 and 4 are similar. What does it mean for number 3 where it says they're complementary? What does it mean about the two angles if they're complementary? They add up to what? They add up to 90. So you should probably write that down, right? We're given that angle 1 and angle 2 are complementary. Thank you very much. We're also given that angle 2 and angle 3 are complementary. I'm going to do double quotation marks to say same dumb thing. This is what we're trying to prove, that 1 and 3 are congruent. So given this information, if I know 1 and 2 are complementary, what does that also tell me? We just said it. What? They equal 90 when you add them up, right? So I know that angle 1 plus the measure of angle 2 must add up to 90. Write what you know. 90 degrees. Well, I also know that measure of angle 2 plus measure of angle 3, it's my pink angle, adds up to 90. So again, write it down. I don't even know if this is useful, but I'm going to write it down. Now, how do I know this? Well, it's the same thing for both. It's by definition of complementary, right? So by def. You know it when you see it, right? If you feel like it's something you know when you see it, it's probably by definition. Right? It's how we define complementary. Complementary is when two angles add up to 90. And look, they add up to 90. Right? Fits the definition. Now, what do you notice? Is there anything else we can pull out of this? Like any other things that we should write down that we know? We know they're complementary, therefore we know this. Is there anything else? I can't think of anything. So what can we do with this? What do you notice? Angle 1 plus angle 2 plus angle 2 plus angle 3 would get us a straight angle. That's true. That's true. We could write that. I'll explore that in a second. That's not a bad idea. Yeah. So check it out. What he's noticing is that we have angle 2 in this equation, and we have angle 2 in that equation. That's the common link between them, right? So if I can switch out that angle 2 for something with angle 1 in it, then I've got angle 1 and angle 3 in the same equation, which is good. It's not exactly what we need, but it's closer, right? We need angle 1 and angle 3 in some equation together, right? So how do I get rid of that angle 2 and replace it with angle 1? Well, if you look at the top equation, if I move that angle 1 over, I'll get angle 2 equals a bunch of junk, right? And you see how I can take that bunch of junk that has angle 1 in it and then switch it out? Let me show you what's going on. So I'm going to take that top equation, and what I'm going to do is this. Measure of angle 1 I'm going to subtract that from both sides. So I'm going to pause for station identification right after this. That way you can catch up and see what's actually going on here. So what I'm doing is the subtraction property, right? If you want, what you can do is number these equations, number 1 and number 2, and say, look, I'm using equation number 1. So all I did is rewrite equation number 1. Angle 1 plus angle 2 equals 90, right? But I'm subtracting that angle 1 from both sides. We cool with that? Again, that angle 1 is the blue angle. We cool? All right, now what does that get us? Well, on the left side, this goes away, and we get measure of angle 2 equals 90 degrees minus the measure of angle 1. And that's a therefore symbol. That's just us doing algebra, right? That is the result of what we did in the last step. So now I know what measure of angle 2 equals. It equals this crap right here. So wherever I see measure of angle 2 in my other equation, I can plug this in. Now, what does this do? Maybe you don't see it yet, right? You should at least see that what it'll do is if I switch this out for this, I'll now have an equation that has measure of angle 1 in it and angle 3 in it, which is closer to what we want, right? It's a step in the right direction. So let's write that. So taking equation number 2 now, instead of writing measure of angle 2, I'm going to write 90 degrees minus measure of angle 1. Remember, that's what angle 2 used to be. That's why I'm underlining it in green. That used to be angle 2, right? We switched it out. Angle 2 is this stuff. So wherever I see angle 2, I can take that stuff and plug it in. So I did. Now we're on plus measure of angle 3. And that equals 90. So I'll pause for station identification once again. Do you see how I took equation 2 and switched it out? What property allows us to do that? Substitution property. SUBS for abbreviation, right? Not SUB, because that could be subtraction. So now I have angle 1 and angle 3 in the same equation. That's good. Okay? If they are congruent, if they're the same dumb thing, then there should be a way to mess with any equation that they both are in and get it to say this, right? Should be true. So how do we get angle 1 on one side and angle 3 on the other? Right? Add measure 1 over. Subtract the 90 from both sides, right? All that stuff. I'm going to grab a separate sheet of paper so I have some more room. I would encourage you guys to do the same when you're doing this proof. That way if you make a mistake or run out of room like I did, you're still good to go. So what I'm going to do is I'm going to ignore those brackets because I don't need them. It's all addition and subtraction, right? So I'm going to write that out just in case that's confusing you. Okay. Nothing new there. Are we cool with that? Okay, I'm going to slide this up. That way we have more room. And you can see it over my head. All right, so what I'm going to do is I'm going to move angle 1 over, and I'm going to move the 90 over. That way I get angle 3 on its own and angle 1 on its own. Is that cool? All right, so here's what I'm going to do. I'm going to do it all in one step. What am I going to do to move the 90 over? Subtract, right? So here's 90. I'm going to subtract the 90. Then we're minus measure of angle 1. What am I going to do to move the angle 1 over? I'm going to add it. So add measure of angle 1 to both sides. Gross. I don't know what got on there. Art. Now remember, if I do it to one side, I have to do it to both sides. That's algebra, right? So what did I do to the left side? I subtracted 90, right? So I have to subtract 90 from this side. I also added, that's what that says, measure of angle 1. Still with me? So what property allowed me to subtract the 90? What property is that? So we did subtraction property, SUBT. What was the other property we used in this one step? Addition, right? We added angle 1 to both sides. And the add prop. Okay, so what does that get us? 90 minus 90 is 0. It goes away. Negative measure of angle 1 plus positive measure of angle 1 goes away. That's why we did it, right? To move them. So all we're left with on the left side is measure of angle 3. And we have an equal sign. Don't lose your equal signs. What's 90 minus 90 on this side? 0. It goes away. So all that's left over there is the measure of angle 1 that we added by moving it over. There we are. Now, we need two things here. One, it says angle 1's got to be on the left side for us to be done. Number 2, it has to be a congruent sign. Now, we're allowed to switch from equal to congruent as much as we want in here. That's free. Okay, I'm giving that to you. So we're going to do two things for the price of one. We're going to flip these and turn that into a congruent sign. So first off, here's our congruent sign. This was a therefore. And now measure of angle 3 is on the right, and angle 1's on the left. Now, why are we allowed to switch these two, where we write one on the left, one on the right, and reverse them? Symmetric property, right? Symmetric property. Swag box. We did what they wanted. Oh, sorry. If I'm saying congruent, do I need measure symbols? No. Just angle 1 is congruent to angle 3. My bad. Numbers are measures. Measures can be equal because they're numbers, right? Figures are congruent. All right, I'm going to walk you through it again, okay? It's a little bit of a beast, right? So here's what I did. I knew I was given this, that 1 and 2 are complementary and 2 and 3 are complementary, right? And we know that that means 1 and 2 add up to 90 and 2 and 3 should add up to 90, right? That's the definition of complementary. So far, so good, right? Just writing down what I knew and a logical conclusion from that. I numbered my equations so you could follow along. You don't have to do this. Looking at equation 1, I can rewrite that by moving over angle 1 to the right side, right? And I did that to get measure of angle 2 on its own. Why did I want to get measure of angle 2 on its own? Because look how both of these have an angle 2 there. I want to switch out that angle 2 for an angle 1, right? So I need to get angle 2 on its own so I can say that's what angle 2 is. So I can take that crap and plug it in here. And then I've got an equation with angle 1 and angle 3 in it, which is pretty close to what I want, right? It's a good step in the right direction. So I did subtraction and moved that over. And I got that measure of angle 2 is going to equal 90 minus that angle. Bam. There we are. Now that I know that angle 2 is that junk, I can take that junk and plug it in where angle 2 used to be, right? See the green? Now I'm here. I've got an equation with angle 1 and angle 3 in it, and some extra junk, but it's all right. That substitution property gets me closer than I was. After I have that, that's where I ended up. I want to get angle 1 on one side, angle 3 on the other side. Move the angle 1 over, I move the 90 over, and we get this. And then we're basically home free. How do you feel about this much? Pretty good?
Yeah.
Pretty good going from complementary to they must add up to 90, right? Cool. How do you feel about taking that first equation and subtracting stuff? If that confuses you, ignore that line. How do you feel about taking that and making it look like this? Can you see it? Taking this, equation 1, and making it look like this. Do you see what I did there? I subtracted 1 and moved it over. Okay, do you know why we did that? Because I saw that these both have a measure of angle 2 in it, right? And I want to get something where it has angle 1 and angle 3 in it. I've got an angle 1 and 2 together. I've got an angle 2 and a 3 together. If only I could get angle 1 and 3 together, right? Then I'd be closer to my goal. So I'm going to switch out that angle 2 for an angle 1. And the way I do that is I need to know what angle 2 is, right? So I got to get angle 2 on its own. Now I know what angle 2 is, so I can take that bunch of junk, and wherever I see angle 2, like here, I can take that bunch of junk and plug it in there. And that's what I did. This used to be measure of angle 2 plus measure of angle 3 equals 90, right? That's this guy. Right? That's what it used to be. but I switched it out for this stuff. So instead of writing measure of angle 2 right here, I can just write this junk there. Do you see how that gets me an equation with 1 and 3 in it? And that's what I need. I need something with 1 and 3. Oh, sorry. I need something with 1 and 3 in it. So I don't know how this is going to work out ahead of time. I just know that I need to get 1 and 3 together somehow, right? And then hopefully if they're congruent, I'll be able to mess with it and get it to where it says they are. So I've got 1 and 3 in the same equation. We're almost done, right? All I got to do now is take that stuff, move stuff over, and eventually I get that, hey, look, they do equal each other. Call it a day. Do you feel better after I went through it that last time? A little bit better. Do I have you somewhere between 25% and 75% understanding at least? Somewhere within there. I'll take that. I'll take that. All right. Number 4, wrong one. Sorry. Number 4 and number 5 are going to be on your own. We're talking about supplementary, right? What does that mean? They have to 180, right? So you're given supplementary. Step 1 would be to write your two equations. Hey, they're both going to be equal to 180. Now you need to prove 2 is 3. We've got 1 and 2 together, right? We've got 3 and 4 together. How do we get 2 and 3 together? Well, that little extra bit right here is going to be key. 1 and 4 are the same, which means you can switch them out, right? 1 is 4, 4 is 1, so wherever you see them, you can just switch them out for whatever you want. So what if I know 1 is 4, right? I have an equation with 3 and 4 in it. I have an equation with 1 and 2 in it. If 1 is 4, well, I can write something with 4 and 2 in it. That's pretty useful. And 4 and 3 in it. Well, if 4 and 3 go together and 4 and 2 go together, I can switch those out to get 2 and 3 together. Give that one a shot. That's not going to be easy, but I want you to give it a shot. Today, what we're going to do is we're going to work on some proofs together in class that aren't the homework. Here they are. So I would encourage you to get some graph paper. Go, 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 go. Send a representative. If you don't want to send yourself, direct democracy is always encouraged, but you know what? Sometimes the representative system is useful. I am so excited that by the end of the year, this taped down piece of paper will be a work of art. Won't it? Also, I've decided instead of just throwing away all my old notes that we use in class, like this stuff that is really just scratch stuff, I'm going to make a mural in the back of the room. Do something with that blank wall. Upcycle instead of recycle. I was
wondering why you didn't like posters or anything.
Yeah, I mean, I don't want to spend money on stuff.
Makes sense.
Also, people put up posters so you guys don't have to memorize formulas, but like, we don't have to memorize formulas in here. We just have to understand them, right? Yikes.
Hey, I did it earlier and I baked it.
Yep.
Off.
I love that logic. Hey man,
whiteboard.
I made a basket once, so it's fine.
Yes,
Right?
perfectly fine.
I made it once, so it's totally fine. All right, so here's the deal. Here's a fun little problem. All right, so check it out. There's this diagram. Let's cover this up. I would encourage you to copy down this diagram. I added in the color and the labels given what they gave us, right? Because words are hard, but math is easy. I think pictures paint 1,000 words, and sometimes that's what we need, right? So ignore the top part. I decided against that one. That's what happens when you make stuff up off the top of your head. So we're here, okay? We've got this crown-looking thing. They tell us that angle ABC, that's the pink angle over here, the big one, is congruent or equal to the measure of angle DCB. DCB, that's not what I wanted to write. I wanted to write ECB, EDB. EDB is what I wanted. I think it's what I wanted. Because DCB, check it out, DCB is this angle right here. That ain't what we want. That ain't what we want. At least not for today. I'm jumping too far ahead. So scratch that out. It's not going to be DCB. What are we going to name this angle right here? This pink angle? What is the name of that angle? Yes, Autumn.
Can you make that bigger?
I can.
Thanks.
How about that? What are we going to call this angle? Oh, come on. Give it a name. EDB. Sounds good to me. That's what they give us. They also tell us that CBD, this blue angle, is equal to CBD is equal to CDB. D is in Danny. B is in bar mitzvah. I hope I'm invited. So we're trying to prove that ABC and EDC are the same. So let's highlight what we're trying to prove. ABC is this angle, isn't it? ABC. And EDC is this angle. So that's what we're trying to prove. It's not given to us, but we're trying to prove. How do we go about doing this? Well, it seems silly, but I'm going to write it. Here's what we're given, right? We're given that measure of angle ABC is the same measure as EDB. The two pink angles are congruent. That's all they're saying. They also tell us that the two blue angles are congruent. That's CBD. And CDB. That's a D. Cool. So these two are equal.
The bell's gonna ring.
I know it's going to ring. So what do we do? How do we solve? How do we get to this? No.
EDC.
Simpler problem.
Of course the blue is going to
What if I gave you this? What if I gave you this? I want you to try this on your own. Add this to your homework. What do you notice about these two angles, the blue and the red?
They're both angles.
They're not the same.
Both angles that are make up that one.
Yeah, they both add up to the pink one, don't they? What postulate is that? Angle addition postulate. That's where you got to start. Go get them.
Genius.
Go get them.
I'm saying go get them.
See you tomorrow.
I know that I'm not going to be home
That
until 8
Saturday
o'clock,
with
9 o'clock at night.
varsity plays at Sterling High School.
Nice. So right next to my house.
Yep.
Awesome.
Should be there.
That means you don't have an excuse.
Saturday?
Yeah.
I might be in Chicago.
Alright.
I got gigs, man.
Oh boy.
You should invite me.
To a gig? Pretty sure it's 21 and over.
I'll slip
I could be wrong. Yeah.
21 and over. Well.
You big sad. Can I run up to my locker?
Yes,
Get a granola bar?
Go!
Can I be maybe 1 minute late?
Yes, go.
Thank you.
Grab me.
Okay, I will.
Yo, what up?
Ellie.
Huh?
Ellie,
My
come
friends think
with
I'm
me.
dumb.